Let's continue our lectures on polynomials. Finally, we're at this point now. We can discuss solving polynomial inequalities. We've talked about inequalities for linear equations, but we never discussed it for higher degree polynomials. To be honest, this solving inequalities is something that you can generate for any other type of function, as long as the functions are smooth, not smooth as in the sense continuous. That means the functions are connected. So what I'm going to do is show you the steps to solve polynomial inequalities. Later on, you can use it for other type of functions as well, just not for polynomials only. What do you do first step? These are the steps to solve any polynomial inequality. The degree of the polynomial does not really matter. It could be second degree, third degree, and so on. The textbook tried to separate them, but I'm not a fan of that. So I'm going to stick with this format and show you how to do this. First important step is change the inequality to equal. The inequality, let me say this. Change the inequality either way, either one of these, to equal sign. And solve the equation. And solve. You'll find some zeros, a solution. Then second step would be draw the number line. Draw the number line. And find the zeros on the number line. Find the solutions on the number line. On the number line. Means, for example, if -1 was a 0 here, if you found out x equals -1, figure out where the -1 is. Okay. Now, here's the important part. Third step. Pick test points. Where do you pick the test points? In each section. Section of the number line. So if you have a solution like -1, and now the -1 splits the line into two sections. One is the left side, the other one is the right side. You pick a test point on the left side, pick a test point on the right side. So that means, that's what I mean by picking a test point on each section. And what do you do with those test points? Pick it on the each section of the number line and replace it into the original inequality. Place it in the original inequality. And what do you try to figure out? To find if it satisfies or not. If it's a true statement or not. True statement. Is it true or false statement? Maybe I should say that. True or false statement. If it's true, you'll accept that section. If it's false, you do not accept that section. That's it. There is nothing complicated about solving polynomial inequalities. It turns out you can say the same thing for other type of functions as well, but our main focus is on polynomials and maybe rational functions as well later on. So here's an example. You're given a polynomial, x plus 1, x minus 2 greater than or equal to 0. One big mistake that I see students do, this is not correct. Do not do that. Or x minus 2 greater than 0. This is not correct. This is wrong. You shouldn't do this. It's not an equality to do that. So what do I do first is I'll try to, let me erase this. Okay. What I do first step is change this inequality to equal. Nothing has changed. Everything is the same. I change the inequality sign to equal. And what do? I try to solve this equation. This is already in the factor form. Now I can say, since this is equality, one of these two parentheses must be 0. So either x plus 1 is 0, which means x equals -1, or x minus 2 equals to 0, which means x equals to 2. Step 2, draw a number line. Find those zeros on the number line. Here is -1, here's 2. I'll put them in order, -1 and 2. Here's an important thing that I didn't mention it through the process in the above section. What it is you look at the original inequality. If you see equal option, that means you can pick those numbers to be in your solution or not. If there is equality, that means these numbers could be in the solution as well. If this was strictly greater than 0, then -1 and 2 are not acceptable solutions. What do I mean is, I'll go through the process. So here I see equality, which means I will pick close points for these two. It means they could be part of the solution just because they have the option to equal. Which means if you replace 2 into the equation, what do you get is 0 greater than or equal to 0. This is true. But if it was strictly, I cannot pick 0 and say 0 is greater than 0. That's not possible. So here, -1 and 2, they're acceptable both. Then I will pick test points. Test points, in this section, I'll pick a test point. In the other section, I'll pick another one. And here is another. You have two numbers, divide the number line into 3 sections. In each section, pick a test point. I'll pick here less than -1, I'll pick -10. Between -1 and 2, I'll pick 0. The number doesn't really matter. I'll just pick any number. You can pick 3, 4, 5. Here, I'll pick 10 again. And normally it's easier, it's better to pick numbers that makes it easier. 10 maybe it's not a good choice, 3 might be a better choice. But I'm just showing you that you have the option to pick any number that you want. What do I do with these test points? I will replace them into the original inequality. -10 goes back into the original equality. -10 plus 1 times -10 minus 2. Is it greater than or equal to 0? Left side, this is -9, and here is -12. Here's the problem. -9 times -12 is a big number. That's why picking -10 was not a good choice. But what do I get is a positive value. -9 times -12, you'll get 108. Is 108 greater than 0? Yes, it is. So what it means that this section is an acceptable solution set. What it means is this whole thing, this area, everything is, any other number that you pick still satisfies the equation. That's why just a sample is good enough. -10 was a good sample. What if I pick 0 and replace it with an inequality? You get 0 plus 1 times 0 minus 2. Is it greater than or equal to 0? And what you get is -2 greater than or equal to 0. This is a false statement. Here is it true. So this is not acceptable, this section. This middle section is not acceptable. And what if I pick 10? You will get 10 plus 1 times 10 minus 2. Is it greater than or equal to 0? Left side is a positive value. 11 times 8 is 88. Greater than or equal to 0. Yes, it is. So this is a true statement. That section is acceptable. So it means all these two sections, they're both acceptable solutions. So what is the solution to this inequality? Finally, here's the important part. This number was acceptable. So everything above this section, do not use the test point. The test points are useless at this point. It's just to show you which sections are acceptable. Don't write -10 or 10 in your solution. The solution only depends on these two numbers. That's why we figured out those two first. So here, I'll say from -infinity to -1. From -infinity to -1. Do I use close parentheses or bracket? Since you had the equality, that means that point was acceptable. That's why I put a dot there. Bracket. Union. Again, 2 is acceptable to positive infinity. This is the solution. You'll see there is nothing complicated about it. So what is important is that you figure out all these solutions. Then use test points. So that's why we focused first on finding the zeros of polynomial, then we discussed the inequalities. Here's another example. Let me write this better. My handwriting is not good. A squared greater than or equal to 3a. Let me change this to strict. So we have done examples of strictly equal. Okay, what do I do first step? Change it to equal sign. Let me use a different color. A squared equals 3a. How do I solve this? Do not divide by a. Move everything to one side. A squared minus 3a equals 0. If you miss a solution, then your answer would not be correct. You have to figure out all the correct solutions. Factor a minus 3 equals 0. What is the solution? Either this is 0 or a minus 3 is 0. So either a is 0 or a equals to 3, which means a minus 3 was 0. So I found two solutions. Again, draw the number line. Let me draw it down here so we have enough space. There's the number line. Here's 0, put them in order. 3. Okay, what do I need? Next step. I need to pick test points. I recommend to draw an arrow just to show that the test points are not useful at the end. They're just to show you which sections are correct, so you don't mix it up with these real solutions 0 and 3. Is 0 and 3 in part of the solution? Not really, because you have the strict inequality. That means at 0 I should put an open circle. At 3 I should pick an open circle. That means these are not acceptable. Test point less than 0, I'll pick -1. Between 0 and 3, I'll pick 1. Greater than 3, I'll pick 4. I don't need to pick huge numbers. These are just good enough. Replace each one into the inequality. If I replace -1, what do I get? -1 squared greater than 3 times -1. Is it true? Yes, it is, because you'll get 1 greater than -3. This is a true statement. It means this section is acceptable. If you pick 1, what you get is 1 squared greater than 3 times 1. 1 is not greater than 3. This is false. That means this section is not correct. And if you pick 4, 4 squared greater than 3 times 4, what you get is 16 greater than 12. This is a true statement. Therefore, that last section is correct as well. It's not always this form that is the left side is correct, middle is incorrect, and the right is correct. This is not formal. Just because these two examples had this result, you cannot always guess it. So these two are the sections that we accept. What is the solution? The solution is -infinity to 0, to this number 0. Parentheses, since we have strictly, that's why we put an open circle here. That means that point is not acceptable. Union 3 to positive infinity. Okay, I hope it is clear enough. There is nothing to it. It's just you picking the test points and replacing. That's why it's important to draw this arrow just to show that these numbers are useless after. Do not mix it with the 0 and 3. Here's another example. X plus 3 times x plus 1 equals less than or equal -1. What do I do? X plus 3 times x plus 1 equals -1. This is your first step. How do you solve it? You cannot say equals -1, so I distribute x times x squared plus 3x plus x plus 3 equals -1. Add the -1 to the other side. What you get is x squared plus 3x, plus 4x plus 4 equals 0. So what do I get? X squared plus 4x plus 4 equals 0. Can I factor it? Can factor it. X plus 2 squared actually equals 0. And write it this way as well. X plus 2 times x plus 2. That's the same meaning. So what do I get? X plus 2 equals to 0. That means x equals to -2. That's the solution that we get. It's only one solution as well. So I draw the number line. I'll pick negative 2. And is negative 2 acceptable? Yes, it is, just because you have the equality. I'll say this is a closed point here. I'll pick test points. Go test point. Less than negative 2, I'll pick negative 3. Greater than negative 2, I'll pick 0. You can pick negative 1, 0, 1, 2. Just be careful. Do not pick something like negative 1 here. Negative 1 is not less than negative 2. Negative 1 is somewhere here. Those are common mistakes. Negative 3. You can always pick numbers that are a bit further just to avoid making mistakes, something like negative 5. But I want the numbers to be not that large, so I can calculate without using calculators. So I pick negative 3. Test these numbers. I replace negative 3 into the original equation. Negative 3 plus 2 times negative 3, plus 3 times negative 3 plus 1. Is it less than or equal to negative 1? This was the original inequality that I'm focusing on. Negative 3 plus 3 is 0. 0 times whatever is 0. Is 0 less than or equal to negative 1? It is not. So I cannot accept this section. Negative 1 is not larger. 0 is larger. And how about if I replace 0 into the equation? What do I get is 0 plus 3 times 0 plus 1. Is it less than or equal to negative 1? 0 plus 3, 0 plus 1, you'll get 3. Less than or equal to negative 1? Not really. So this is not acceptable either. So what is the solution to this inequality? This section is not acceptable. The other section is not acceptable. There is only one number that is acceptable. And it turns out the answer is x equal to negative 2. There is no interval. There is only one number that satisfies this equation. You can write it as this as well. You can write it in the bracket and say negative 2. Like this. Single numbers, normally you can write it as in a bracket form. If this inequality was strictly less, then this point was not even acceptable. Then in that case, you would say no solution. Nothing satisfies this inequality. Empty set. But in this case, since you have the equality option, then there is one solution. That solution is simply negative 2. It's not an interval anymore. This is just another example. So you see, sometimes it's only one single point. Sometimes there is no solution. And here's an example of having a third degree polynomial. Because if you multiply all these, you'll get a cubic polynomial. And we want to figure out what is this inequality. The solution to this inequality. Change the inequality to equal x plus 2, x plus 5, 2x minus 3 equals 0. What are the zeros? X equals negative 2, negative 5, and that one is 3/2. So I'll draw the number line and put these numbers on the number line. Here is in order, negative 5, negative 2, 3/2. You do not need to be specific how much gap do I put between. That's just enough so you can write another test point in between and say, let me use a different color. Let's say test points here, test point here. Now you have 4 sections to worry about. How about these points? Are they acceptable or not? You look at the inequality, say open circle, because you have a strict inequality. The strict inequality means not acceptable points. Okay. Test points, negative 6. Here, I'll pick negative 3. I'll pick 0. I'll pick 2. These are my test points. Replace it back into the inequality. I'm going to go through the process a bit faster. Minus 6 plus 2. Minus 6 plus 5. I'm going to do it for a couple of them. 2 times negative 6 times negative 6 plus minus 3. And is it greater than 0? You'll get negative number, this is negative, and here you have another negative. Negative times negative is negative. Greater than 0? Not really. So this section is not acceptable. If you try negative 3 plus 2, negative 3 plus 5, 2 times negative 3 minus 3. To see if this is greater than 0, what you get is negative. positive, negative. The result is a positive number is always greater than 0. Yes, it is. And then try 0, you'll get negative, positive times negative, you'll get not acceptable, and you'll have an acceptable solution. I didn't go through all the numbers, but you can try it. So what are the solution set? Is this section plus this section. These are the two solutions. Normally it's alternating, but not always. Okay. So what is my solution? The solution is from -5 to -2. And since they were open parentheses, since they were open circles, neither of these points are acceptable. I use parentheses. And here, union 3/2 to infinity. These numbers are what you care about. They should be exactly depending on these three numbers, nothing else. Okay, I hope this was clear enough. Let's see if there's one more example. I have another example just to show you as well. This is a good one as well. So here, let's solve this inequality. X minus 7 squared equals -4. I'm gonna square this. X squared minus 14x plus 49 equals -4. X squared. There is a shorter way to solve this, by the way. I do not need to go through this, but in case you're not comfortable with that, I'll show you the shorter way in a second. Minus 14x plus 51 equal to 0. And what you can do is you can use quadratic formula. X would be 14 plus or minus square root of 4 times this 14 squared minus 4 times 51 divided by 2. You see, all these numbers are very large, and when you simplify it, you'll end up with 7. 14 divided by 2 is 7. Here, 14 squared minus 4 times 51 is plus or minus 2i. You'll get something like this. These are your solution, x plus or minus 2i. The faster way would be from here. Just take a square root from both sides. What do you get? X minus 7 equals square root of -4. It's minus 2i or plus 2i. These are the two options. So plus or minus 2i. The square root of -4. And what is x? X equals, add 7 to both sides. 7 plus or minus 2i. This is the two solutions that we get as well through this process. Okay, so I draw the number line. Where do these two solutions go? 7 plus or minus 2i. Can I write 7 plus 2i here and 7 minus 2i here? Not really. This is what you should be careful about. These are complex numbers. This is a real line. But the complex numbers do not belong to the real line. That means there is no solutions for the real line. None of these numbers are acceptable on the real line, so I didn't find any solution. So how many sections do I have on the real line? There is only one section. I'll pick a test point. My test point, some number, 0. You can pick 10, 100, whatever you want, because there is only one section. I'll pick 0, for example, as simple. Let's try 1. Just so you say, I picked 0. You do not need to always pick 0. What do? I replace 1 into the inequality. 1 minus 7 squared, is it greater than -4? And what you get is -6 squared is 36. Greater than -4? Yes, it is. So that means this whole real line is acceptable. That means, what is the solution to this inequality? All real numbers. You can say from -infinity to +infinity. It doesn't depend on this test point at all. And does it make sense? Yes, it should make sense, because what you have originally on the left side is a number squared. Any number squared, the result is positive. What you have on the left side is a negative number. Positive is always greater than negative. So any number that you pick satisfies the inequality. If you get that from the original equation, you don't need to go through the process. But even if you go through the process and you get complex numbers, there is no way to put the complex numbers on real line. So I cannot accept these two solutions. on the real line. So my real line is only one section. It hasn't been broken up. So I just need to pick one test point and go through that. Okay, I don't think there is more example. Yeah. So I'm gonna stop here. You can try more examples, but I think this would be good enough.